So okay, hello, good morning. This is the first stream that I'm doing on Twitch instead of on Facebook Live. They used to be on Facebook Live, so I'm gonna put them afterwards. I'm gonna put them on YouTube, and hopefully it's more reliable than doing them on Facebook because I cannot. I wasn't allowed to do today the live video for some reason. So anyway, today we are gonna um, create the with my create a Pong style game with my library and with my game framework, HTML5 game, JavaScript game framework. Um, there is a I will write in chat. The source code of the source code of the microgame framework is in the URL that I have pasted in the chat. Yeah, and as usual, if you have some question or something, please tell me, and we can go through it. Today we are gonna start with the basics of it and how it works, and yeah, basically that's it. A little bit of the development, and I'm gonna show you some tools that I have that are still not released, but I have them here. So yeah, so far this is what it is, what we have in the browser, and yeah, the library is loaded. I have created this group file that just copies everything and compresses the HTML. We do everything in the mostly everything on the HTML file itself. So yeah, yeah. So far, all of the streams are gonna be on Twitch, and yeah, this is what it's gonna be. Hopefully, they can go to YouTube or something afterwards, and yeah, I will create. I have to still create a channel for it and so on, but yeah. So yeah, this is the basic HTML and some style. Um, um, don't remember. Yeah. So the for to initialize and we pass here, we create the object of the engine, and then we pass the function and the size. You can the function is, for example, found. I always like to call it update, and we can do console.log STUMGE engine dot frame count, and then we do engine dot init, and we pass the update function here, and the engine basically detects already a canvas with the ID, with the correct ID, and now we have the canvas here because it's intended to look like a Game Boy. This is the original size of the Game Boy screen, and the idea of this game engine is to bring the a little bit of old school programming experience to the web. So we can do here. We can we can pass a configuration dictionary, and so far there's not so much configuration, but you can say that the scale, for example, is 4, and that multiplies the size of the original screen times 4. So now we are working with this, and because it's intended to look as a Game Boy, this is the default palette, even though you can edit the palette as well, but this is the default palette. So yeah, so essentially this is the canvas we are working with, and this is this is everything that we have needed to code. We create the engine, and we initialize with the update function, and of course if we come here and we press F12, well, not anymore, we have to inspect. If we go to the console, it's printing the frame count. This frame count is a property of the engine that counts the frames that have passed since the start. The engine is designed to be more or less like a is designed to run like a 60 frames per second, more or less, and that's it basically. This is very manual, so I'm gonna show you now a tool that I have to create the sprites for this engine. So it's a tool that I have coded in Python, and it's very, very primitive. It's very incomplete. So it's not released even yet. So yeah, I'm gonna create first how it should look, the right palette, because we are gonna create a clone of a clone of I forgot to publish on Twitter. Oops. Okay, so now we are creating the palette that it's gonna be on the left side. So I don't even remember the keys. This is, as I'm saying, it's a very primitive tool, so it's not very perfect, and not at all. So I'm open because I don't even remember the keys that were used for this. So Okay, so I want something like 5 wide and 1, 2, 3, 4, 5, 6, 7, 8, and now I start to color it. For example, this is the one that is gonna be on the left side. So you have to think that the screen is, if I remember properly, is 160 by 144. So you cannot create like huge sprites because they will use too much space on the screen. And this is the one on the left. Also, you have to think that that one of the colors is the background color, so it's not so easy to it's not so easy to define the sprite so it looks okay. So so where is it? Projects. We can save it here with the name left paddle.js, and I think that now yeah, this creates the data structure that holds the sprite for us. So we can call this left paddle, and then we can just copy this here, the left paddle sprite, and then we create new left paddle graphics, and then we create a left paddle sprite. It was a new STUMGE sprite, and I don't really remember STUMGE sprite. I have here the libraries here, so we can check the sprite classes, STUMGE sprite, data or stand x and y, so we can put it in like 10 and then we can just paint it left engine dot set sprite, and we do left paddle sprite, and if everything has been okay, now we should have this data is not defined. Damn. So now yeah, we have our paddle there in the position that we have told the engine, the original position. Of course, if we want to animate it, then we can do it as well based on these coordinates that are stored inside the sprite. And yeah, So now we have a sprite. Let's create the other sprite, the sprite which is the opposite of this, and we can add just to keep sanity, like a file in the JS folder, a file which is like graphics.js, and we put this here in the graphics.js just to keep them separate, to keep the data separated, and we can delete this. And then in here we load the graphics before loading the and now it should be the same, except a little bit more clear because we are a little bit less clogged here. So now let's create the right paddle graphics, which is gonna be the same but mirrored. And we save it. And now it should be here. Where did I save it? Done. We need to go to the web projects, web micro game, WE, games, Pong, right paddler. And we cut this and we put it in the graphics. We can delete this now, and in the index file we can do the same. Left paddle, we don't even need to call it sprite. Left paddle, then right paddle, and we put it in like 150, 10. This is AXY. So now if we load this, we are not painting it, of course we are not. And now we don't need to print this. So yeah, now we have the two paddles. For our Pong game. Obviously, they still don't move at all or anything, but it's okay. So the next thing is the ball, and the ball obviously needs to be small. Needs to be small, but yeah. I'm thinking, what is the best way to do the ball? Maybe, I mean, it needs to be needs to be a sprite. So I'm gonna do this once again. The ball is gonna be just just a small circle. So now we save it. The web project, web micro games, WTL, games, Pong. Here it can be just ball, okay, yes. And then we just copy this to the graphics, and then it's ball graphics, and then we can just create the ball, new STUMGE sprite, ball graphics, and we can put it in 50 for example, and then we can just print the ball. It's funny though that it seems to have some shade, so I'm gonna quickly edit that, because probably I have, it's not 2, it's 4 for the top absolute. And now if we load it, it's not, there's no 4, it's 3. It goes from 0 to 3. So yeah, basically this is how you define sprites in this framework, because the idea is to bring a little bit the old school game programming ideas. There is no like graphics loaders or anything. You have to work with sprites, which obviously it's an absolute pain in the ass, but as well you know, it's easier, and it has this this vintage type of way of thinking that I like. So basically this is the idea that I am following when designing this game engine. And now the next step is gonna be animate the ball. So because the ball moves without interaction from players side, it's fairly easy to animate. So the ball is a sprite, but we can add eventually, if this becomes very big, we can just move each of these elements to its own file for clarity, but we can do ball.update equals function with no parameters, and we say, like, for example, this dot x class equals 1, and then we do at the end we do ball.update, and now the ball should be moving quite fast. And now you see the next problem, that we don't clear the canvas in every frame of the animation. So this kind of thing happens. So the first thing that we need to do is before this, we need to do I think it's that I don't remember if there is this is another game that I have the engine.flood screen with color 3. You can choose to flood it. Flood the screen means that it sets all the pixels to the same color. All the pixels on the screen to the same color, which is basically the I'm trying to get used to not to write semicolons at the end, because it seems that that's the best practice. Yeah. Now we have a ball that animates. With this amount of code, obviously it's bullshit, but yeah. So we extended the sprite with this update function, and then call it and then we called it for the animation. Of course, we could say like if this dot x is bigger than engine dot engine dot no, it's not it's if x is bigger than STUMGE width, then this dot x equals 0 and else this dot x adds 1. This is in reality this is kind of the speed of the animation. So yeah, basically yeah, this is the way. So now if we reload this page, we will see that once it goes over that edge, it starts from here. We will need to use some maths for that, because we need to be able to move this with a vector. So it can move like in both directions, essentially. And yeah, but so far so good. Now we have a collision. So yeah, this is we have extended the ball object with this function that updates, and obviously I'm gonna extend the engine with a function that is set all sprites and I'm gonna tell to paint all the sprites, so we can do this easier, because we will need to paint all the frames. We could also consider storing the storing the, oh yeah, we need to do this before. We could consider to move to have a collection of sprites instead of uh, instead of keeping them as global objects. But I think that so far we can keep like this. If it gets very complicated, then we can move on. By the way, for those who are watching now, the source code of the, you can clone the framework on this URL that is in chat, and you can, I would be very happy if you try it out and you create stuff, and I can even host, if you create a game, I can host it and give you attribution and everything. If you like, I want this experiment to be used, because this started as an experiment, but I really want it to be used. So yeah, I'm gonna start also creating stuff in this series. This series used to be in Facebook Live, but now it is on. I'm going to start to do it on Twitch and upload the videos to YouTube for future reference as well. And yeah, and yeah, I would be happy if you also can improve the source code of the framework and propose new features to add and so on and so on. That would be awesome. And yeah, and obviously create games with it. And as I'm saying, I'm more than willing to host them and so on. And also there is one game created with this engine here. If you wanna see, this was the first game that I created with this engine as a kind of proof of concept. So you can as well visit there. And yeah, anyway, let's continue with this yeah, and I'm gonna do the same. I'm gonna extend the engine with a function to update all the sprites that need to be updated. So far only the ball and um, um, yeah. Set flow sprites sprites engine dot update sprites, and we have already done our first refactor, and this is essentially the same. And yeah, the definition of the graphics for the sprites is here. And yeah, I'm checking here that I'm open the source code. I have opened the source code for this can disappear. And yeah, so far so good. Now what I'm gonna do is to make the ball rebound accordingly. Yeah, so now the yeah, I think that the ball is starting to be complicated enough to have to be on their own. So I'm gonna create a new file, ball.js, and I'm gonna move the graphics there. I think it's very important to have the a clear structure in the code, because this can get out of hand very easily. So, and now we come to Pong and we load after graphics, even though the graphics, it wouldn't matter because the graphics of the ball are already on its own. So yeah, and this, what is the problem? Ball is not defined. How is that? How is so that ball is not defined? Ball is defined here. But STUMGE spread is not defined. That's the problem. That we need to load STUMGE, obviously, before everything actually. And now we have the same ball but on a different file. I'm thinking if we really need the right paddle, or because we can just use a horizontally mirrored version of the left paddle, but I mean, we can use the same graphics, but so far this is it. So yeah, this, we need to have ball dot speed equals ball dot speed, because it is a vector, x equals 1. At the beginning the ball is stopped. So now instead of well, it starts moving on the x, but then we need to operate on with vectors. So because we don't want it to move faster in diagonal, we need also to normalize this vector. So it would be, it can potentially, this is something that I will potentially add to the library, like some vector management. That would be useful. But yeah. So now we need to this dot x plus equals ball dot speed dot x, this dot speed dot x, this dot y plus this dot speed dot y, and now and we do the same with the height. And now it should still be moving horizontally. But now if I change this speed to 1 then we are talking of a different story. Moving diagonally, but it's because the 1 the length of a vector, the length of the vector 1 is longer than the length of the vector 1 so it moves faster diagonally, and we want to avoid that, so we need to normalize this before doing anything. And by normalizing means dividing by the length, so it always has length 1, and then if yeah, you can multiply, and of course we need to do if this dot x is smaller than 0, and the same for this. Because now if we put this to -1, obviously this is an error. Now I don't know if this is what we want for the movement, but now we have to normalize. And because this is going to start incorporating fractions, we need to have, because in this xx, yeah, it says that it's an int, so we need to keep ball dot real x equals ball dot x, and ball dot real y equals ball dot y, but yeah, and then we do this dot x equals math dot round this dot real x, and this dot y equals math dot round real y, and real y will have a more accurate value for the so the diagonal moves at the same speed than the horizontal. So this is but first we need to normalize the speed. This let normal speed equals to let speed norm equals to 1. This dot speed dot x divided by speed norm, and yeah, this is a candidate to be incorporated into the framework. This type of vector, a class that represents a vector, and so on, because this could be done like right away with a vector class and so on, but this dot normal speed dot x and normal speed dot y, and then the speed norm is the square root of the squares of the values of the speed. So it's sq math dot sqrt of speed dot x this dot speed dot x times this dot speed dot x plus speed dot y this dot speed dot y for the square root of okay. And you will see now how it moves slower. But that's at the same speed. If I do 2 minus 2, for example, but now instead of this, we need to make it rebound. in order to make it rebound, we are working on the ball now, so in order I'm just testing for different angles. If this makes any sense. Yeah, it kind of works for any angle now with the normalized speed. Yeah, we still don't have collisions with the pads or anything like that, so what we are gonna do is instead of making them work around, we can just we can just change that speed, change the speed. This dot speed dot x times equals -1, and the same here, and the same here, and the same here. I don't know what is gonna happen, but and of course we start with a regular regular speed of 1 to 1. Now let's see what happens. I'm not sure. Okay. The problem is that this is on the top. This is on the top. Our reference point is not in the center, it's on the top. So when you go to the left side or the bottom, then it doesn't. The rebounding seems a little bit funky. And obviously all the changes are 90 degrees, which is not good. We can see how can we slightly randomize that at some point. But yeah, actually this is not speed. This is now that I'm thinking, this is direction. That's why we normalize it. But refactor rename. But if we want to do the speed, for example, ball dot speed, this is a constant, so we can say 4, for example, and then normal speed. Normal speed is not refactor rename speed norm direction norm, and this is not normal speed. This is refactor rename normal direction, and then if we want to be able to change the speed, then we do this, change this dot speed, and this is now the, so now we have to be moving way faster. Yeah, and if we change this to 2, then it will be exactly the same movement but slower. because the speed for us in this context does not have direction, even though it has direction. But we in real life, but we consider the speed and the direction two separate things. This would be the real thing would be that this is the direction of the speed vector, and this is the magnitude of the speed vector, if you consider it like a complex number or something like that. But we can use this notation and it's okay. Anyway, yeah, we can use as well the real numbers here, because we have the real thing. But now I'm gonna fix the fact that it's the top left corner. So if you see, when it comes to the right side or to the bottom, it seems that it gets in. So now this we can say it's bigger than the height minus this dot this the I wonder if there's a there's I never okay. Sprite constructor, rotate the step, horizontal, flip vertical, get copy, get width, get height. So this is minus height minus. So it's when it's bigger than the height. Now it needs to minus this dot get height, and this is the same, but minus get width, obviously, even though in this case it's the same. But now they shouldn't be crashing, like getting into the now it's a proper rebound on the wall. And now we have a ball that moves and rebounds and is animated. So yeah, I think that this is all for today. In the next session, we are gonna move the paddles and do the collision detection and everything. But I really hope that you you give a shot to this engine that I have created, and yeah, and you can always contact me on Twitter or somewhere if you want me to host your game and create it with as long as it's created with this engine, of course. So yeah, I think that this is it for today, and thank you very much for passing by, and see you next week. Bye.